So first of all, when we inject a virtual host bridge into the guest operating system, we need to find some memory holes. And I believe that this is somehow already covered in x86 world. So for what purpose we need those memory regions is for IO and MMI memories, other different memory spaces. So we can have some space to map physical PCI devices memory into the guest. So as of now, what we did, we just introduced some constants into a header file and use those to inject a virtual host bridge into the guest. But those constants may not be suitable for all the systems, and for that reason, it can be that on some platform we might have a situation that those constants will overlap with hardware or some other memory spaces. So we are thinking about that we need to create those some sort of runtime, and that can also depend on the platform. As I already said, that the memory is differently populated in different platforms. So we need to do that at runtime and not having some constants. My bigger concern here is that we started to use header.c. Roger knows that file very well. So it was originally used for identity mappings on x86 for PVH, if I'm not mistaken. But as we develop VPCI on ARM, we do not have QEMU, we don't have any entity in the system which will emulate configuration space access, which will emulate host bridge, etc. We started using that piece of code to actually emulate configuration space for the guests. So it is probably doubled at the moment when we just added simple PCI devices. But I started working on SR IOV support, and it seems like it will double what I have at the moment because I need to handle SR IOV. So the first question to me and probably to the community, what would be the better probably way of emulating configuration space access for ARM? Either we try to put that into common code and hopefully x86 start using that as well at some point of time, or we need to branch out and have some ARM specific implementation of that.
What
So
sort of... Go on, Tom.
So on x86 at the moment, I think we only support the CFC CF8 configuration space accesses. It is a
not really for PVH.
PVH, yeah, PVH DOM0 is a little bit special,
Yeah.
but certainly as far as guests go, we own. That's all that we've got at the moment because we don't have mmconfig or eCam supported. Now, this is something we definitely want in x86. I presume that would be what you want in ARM as well?
Yeah, so on ARM, we already emulate eCam. And this is something which we extensively use, and we rely on that for the guest operating systems. I'm okay that memory regions are on ARM side. This is not a big deal. What I'm worried a bit more is that we start to pull a lot of code which didn't exist there for x86 platform. I mean that we start to emulate things for the guests, just like configuration space, etc. Bars is just an example of that.
Right, but bars are part of the PCI standard. They're the same between x86 and ARM.
Yeah, the question is not that it is different between the platforms. The question is that x86 didn't need this code before that, and it doesn't actually, because that is emulated by QEMU. And in case
it does need it because that code path is really quite broken and not compatible with PVH. So we are going to need that for some of our plans. We just don't have it yet.
Okay, so probably after this working session we can discuss that offline, so I can show our current status. So everyone on x86 world can take a look and say, okay, this is something we also want. So we don't need to branch that for ARM. I mean that emulation. I will put more meat into it. So I am working on SR IOV support at the moment. So right after that, I think that we'll be able to show something to the community, just like RFC or something like that. So we can start discussing that because we do want to upstream that, and we want to align with x86.
I think I've already sent you a link to a series I did long time ago to support SRIOV using BPCI.
Yes, I will also see that series as well, but it has diverged a bit from what we already have on our side. Yeah, so I will definitely I will look into that. This will help. Okay, so basically, I think that this is generally accepted that we move forward to converge with x86 and have common code on at least bar emulation for guests, for both x86 and ARM.
I think in reality, we'll probably get to a reasonably common bit of SRIOV as well, because again, that is part of the PCI spec, not something unique to x86.
It is not, but the main showstopper for me is QEMU used by x86. So
yeah, but we don't want that either.
Okay, so this is because I also always worried about that. Okay, we need that for ARM. x86 has QEMU, so they don't need this code. So will they accept that idea?
We will happily accept an idea that takes QEMU out of the data path.
Okay, great.
Particularly, one thing we would like to be able to do sooner rather than later is to try and get SRIOV working properly under PVH domains, and PVH very specifically has no QEMU in it.
Okay.
So that is something we are looking actively to do in copious free time.
Okay, so this is what I started to work on, so I hope to provide some results soon. Okay, great. So we can go on and modify what we need for ARM, and it will also be consumed by x86. Great. We also need to map a Linux segment to a virtual host bridge. And for that reason, we might probably need a hypercall. So the question here is that the Linux segment.
Sorry, what is a Linux segment?
Domain, okay.
Okay, a PCI
for
domain.
SB, yeah. I'm talking in PCI context. So in case if we emulate multiple virtual host bridges, we need a way to match the PCI segment seen by the guest operating system to the number which is assigned or expected by Zen. So we have to align this SBDF as part of that address. So Zen and the guest operating system are talking about the same thing in the system.
Don't you have a DT node for that?
Sorry, go on.
No, I mean, I remember that you said there was some kind of DT attribute or node or whatever they are called that you could use for that. And then when you use ACPI, you get that from the MCFG table.
Probably yes, this can be injected, but this means that we expect that the guest operating system will handle that from the device tree, and the guest operating system might not be Linux as well.
Yeah, but then if it's not Linux, you will have to implement the hypercall anyway. So
Yeah, so the question is either we have to implement a hypercall or we have to rely on that device tree property. And if you rely on the device tree, then it is okay, it is solved.
yeah, it seems easier probably. I don't know unless that's something I'm not.
It is easier, much
So
easier.
it does sound to me like this is something that would be configured very early in the domain's life cycle and be fixed very early in the domain's life cycle. Now, this isn't necessarily so. We don't currently have any DTB in x86. I'm not entirely certain how we'd go about trying to put DTB into the middle of a create hypercall, but at the end of the day, this will just be a domcuttle create host bridge call or something like that you'd make very early on. And then in ARM, you would write something into the DTB for the guest to do the mapping, and on x86 you'd fill in the requisite bit of ACP table with AML to do the gluing together. There,
I don't think you need AML.
But why do you want to go different routes from the beginning? So if we expect that the same will be used on x86 and you don't have device tree at hand, so why don't we just invent something which will be common for x86 and will not depend on either you have device tree or whatever else?
But you need to fix your OS. You need to tell your OS why is a PCI device.
Yes, and the way you do that is different on ARM and x86. So how we configure the hypervisor with its virtual bridges is a toolstack hypercall. Mm-hmm. How we report that to the guest is via DTB on ARM, which is written by the toolstack as part of building the guest. And on x86, it is partly via the MCFG table and partly via ACP AML, because there are requirements for having certain objects in the AML namespace. To answer one question that went by on the chat.
Okay, makes sense. Then I am not quite sure if this assumption actually is good or not, that we assume that PCI bridges are not passed through. So we only pass dedicated devices, individual devices.
I think that matches with what I'd expect we do in x86. We certainly don't pass any through at the moment.
Okay, great.
We kind of semi-emulate some of them. That's a large amount in QEMU. Mm-hmm. The reality is we never ever actually want guests to be able to play with the real bridges in the system.
And I expect that 256 devices are more than enough to be passed to the guest. So at least at the moment it looks like.
I mean, the moment you put in that limit, someone is going to want to up it.
Yeah.
But yes, that ought to be fine for now.
Next thing is we need a PCI ID for the virtual host bridge.
So Zen has a PCI vendor identifier. It's XS in ASCII, so 535A, something like that.
We already used that.
So yes, there is a document in tree that is there to divvy up the device ID space under the vendor. So if
there is a link in my slide, so actually it references.
Oh yes, sorry, it's there. I was blind and looking at that. So yeah, we can absolutely reserve some standard. IDs.
So we need that. I just stolen one for my virtual host bridge, but I already use Zen server, and the guest operating system can detect me. And for instance, LSPCI is happy to report that the virtual host bridge is Zen server. Okay, so yeah, no objection here. So we'll probably have a patch to reserve some IDs for the virtual host bridges. Some open questions. I put here some work which we didn't start yet. So we didn't start working on multifunction devices yet. SRIOV, I have already started working on that. We are still to decide if we want multiple virtual host bridges, and depending on that, we'll create some more code for supporting multiple bridges if need be. And
I think it would be reasonable to try and plan multiple in right from the start. We're now starting to see hardware that does have multiple PCI domains or segments in it, even if they're not surfaced terribly well at the moment.
Okay, so you're okay if we go with multiple virtual host bridges from the start, okay?
Yeah, I mean, absolutely design the hypercalls with that in mind. So maybe have a linked list and an upper bound of 2 or something to start with. That would be entirely fine to try and make sure we get the infrastructure in place, even if it doesn't necessarily get used right to begin with.
Okay, Andrew, if do you by chance know if this can be emulated on QEMU? So if I want to emulate something on x86 and I want to emulate multiple root complexes, as far as I know, it is not possible to do on QEMU.
I have no idea under QEMU.
The question here is that we need something which we can have in our hands and we can test the implementation.
I did, Bertrand Marquis from home. I did start a discussion internally, but it could be that we could use FVP, so the emulator from ARM, as a PCI emulation, and we could use that to create a system with complex root bridges, or several of them. I started the discussion internally. The question is, can we find a way so that this can be used externally? So we could find a solution for development, but a free one available publicly, I'm still working on that question.
So what I meant was make sure that all the hypercalls in principle work if you want to use multiple. I'm not necessarily saying it has to be there and it has to be tested right from V1. Of course, the first people to actually try it will get to have all of that fun. In particular, modern Intel laptops do actually have a second PCI segment, except it's hidden. It's the RAID controller lives on it, and it's causing a huge amount of fun for Linux who are refusing to take Intel's patches for it. So there are definitely systems which exist that have multiple PCI segments on x86 if you want to go stooging around to find them. And the reality is that servers are basically big enough now that they have run out of space under a single domain. So they are going to be turning multi-domain very shortly.
Okay. Bertrand, do you know if SRIOV will be supported there?
I have no idea, but that's something I can ask. I don't know if it's supported by. I will check that. I can come back to you on this one.
Because this is the use case I'm interested in. And I would love to have some platform which will allow me to emulate that. Currently, I emulate that on QEMU. And that emulation is not complete. And the emulated device, it behaves like a SRIOV device, but it is not fully implemented.
I will check that and come back to you on this.
And it seems from what I see for SRIOV, we are mostly probably limited to Ethernet devices.
Okay.
Okay, so DOM zeroless support is also on our table, and we want this. So we are trying to develop with DOM zeroless in our minds. We also need the PCI back driver for ARM as well. You might remember that I've sent some RFC probably last year, trying to discuss that the tool stack needs a place to store information about which PCI devices are being passed through, which are assigned, which are assignable, which are bound to a driver or not. And for that reason, I introduced some hypercalls, and finally we decided that this is not so good way to go forward. So instead of adding some hypercalls, what we did, we enabled a PCI back driver for ARM as well. We do not use it for configuration space moderation. We do not use that for MSI stuff, etc. So we do not use the PCI front driver at all. So we only use PCI back driver to please the tool stack and to have it as a database for storing such information, as I said. So for that reason, we will also need to modify the PCI back driver because it is really Zen x86 centric now. So we had to modify that, and if accepted, we will also push the patches to the Linux kernel in order to enable PCI back on ARM as well. And
one point there that might be worth considering. At the moment, PCI back is actually two separate things, both rolled into the same driver. One is the functionality for device seizing and arbitrary resetting, and the other is the functionality for speaking the other half of PCI front. I think it would do a lot of people a lot of good if these perhaps became separate concepts.
Yes, there is also a PCI stub driver. So I'm worried about that if we separate that. So at the end of the day, we'll have a PCI stub plus driver. So I didn't get into the code deep enough, but I think that we have to consult what PCI stub already has. As far as I know, it already has some functionality for binding the drivers, etc. So we have to decide how we want to separate that functionality and what part of that functionality will be different from PCI stub.
One thing that occurs to me is that we are almost certainly not the only hypervisor that cares about device seizing and unbinding. It might also be the kind of thing that could be shared with other hypervisors if Linux wants it that way.
Yeah, and PCI sub, as far as I know, it is already used for unbinding. And yeah, we can consider that and see if we can extend the PCI stub, or we would need just to separate PCI back into two different pieces.
And the other option is that we sit and try and not reinvent the wheel, which might also help.
In that way, we need to change the tool stack to rely on two drivers, and one of those drivers could be PCI stub.
PCI stub is what used on KVM, I guess.
Mm-hmm. It is already used and maintained in the Linux kernel, so we'll get it for free, in case if we change the tool stack.
Basically, I think KVM has something similar like PCI stub already. So with a little bit, some differences, but not too many. So the role is basically the same for Xen PCI stub and KVM PCI stub.
I think that PCI stub is a common driver, so any hypervisor can use it. And it is, you can use it as is. So just if you want to hide some devices from the system, you can unbind and bind those devices to PCI stub. This is not specifically for hypervisor.
In which case, we ought to see about dropping the bits of functionality that are duplicated there, because I guarantee you one of those will be better maintained than the other.
Yes. The last thing from my side, we are also using a use case. We have a use case where hardware domain is not domain zero domain zero. Some sort of we just move the real PCI devices into other domain, and for that we created some daemon, which is Zen PCID, which solves a problem that the current tool stack implementation is too coupled to the knowledge that all the PCI stuff lives in domain zero only. So it goes directly into sysfs for PCI, etc., to reset devices, to get MMIOS, etc. And we created a POC, which is available at the link below. So we created, using libvchan, we created a daemon which talks to the tool stack and can live in any domain which owns real PCI hardware. So for that, we created this and already tested that. And at the moment, it works for us. So we also are seeking for some ideas if this is a good way to go as well. So this will enable the use cases where PCI does not belong to domain zero.
We also have something similar for not PCI devices, but PB devices in general, that's called XL DebD, which you could maybe try to integrate this functionality there, because that's already a daemon that's used on driver domain. So it might be useful to have that functionality integrated.
Yeah,
there.
we do not want to introduce entities if we can integrate something, but we just created that to showcase what we want and why and how.
Yeah, I mean, XLDebD, I think it's slightly different because it relies on XenStore to set up the devices and so on, because it's based on, well, it's designed to manage PV devices that are handled using XenStore. But I guess you could see about having, I don't know, another listener or something like that listens on some kind of libvchan maybe.
Mm-hmm.
I mean, it would be nice if it was only a single entity.
Yeah,
and you could
sure.
handle everything from there. But I don't think using XenStore is a good recommendation.
No, it is not. Okay, Rahul, which slide do you want me to show?
Slide number 9. Yeah.
Just a second.
Yeah. So currently we are in a process of implementing the virtual ITS for the DOMU guest. So there are, that I discussed in the session, there are two possible designs then we can implement for the virtual ITS. So one is, like, as I mentioned, one is to create the same number of virtual ITS as the on the physical, as same number of virtual ITS as we have on the SOC. And in that case, there will be a direct mapping between virtual to physical ITS. But for other, and for in that case, we need to change lots of code. Like, we need to introduce hypercores to find which virtual ITS is mapped to the physical ITS and how many physical ITS is available on the system, because this information required by the tool stack to create a device tree node. And we also need the information from Zen also. So there is an MSI property that we have to be filled when we create a virtual host based device tree node. So this, when this device is assigned to the guest, to which virtual ITS it can inject an MSI interrupt, so that Linux can configure the MSI domain correctly. And but other design is like we will create only a one virtual ITS, and that will be mapped to the all the physical ITS. But we in that case we need to trap the PCI MSIX control and MSIX table and configure the real physical ITS based after trapping into the Zen. Yeah, I thought I will discuss with the community which is the better design to go.
Now I think that we have to account on the idea of Andrew that we'll have to probably account on multiple virtual host bridges.
So yeah, so in
Well,
that
what I'm saying specifically is don't make the design depend on a single host bridge,
Yeah.
because otherwise you're going to have twice as much work to unbreak that in the future. So it's fine to only implement the bits that are currently used, but don't deliberately design it with a restriction that there can only be one host bridge.
Okay. Yeah.
As for this, when you're talking about ITS, that's the interrupt controller.
Yeah, that is
Is it not?
Yeah, MSI controller for ARM SoC. Yeah.
And where are those? Is it one per host bridge, or
Yes.
is it
One per host bridge.
The problem with the one-to-one stuff is that it adds a lot of overhead, I guess, because you need to, I mean, if you have devices hanging off different physical host bridges, you need to create all those virtual host bridges to have the one-to-one mapping. So if you have 3 devices and they all hang different physical host bridges, you need 3 virtual host bridges then.
Yes, correct.
I doubt you are going to get very far if you try and merge, or in the guest's view, attempt to merge what is multiple physical host bridges into a common view. I suppose you can probably make it function, but the guest's idea of IO Numa is going to be totally messed up.
It's also going to be quite a mess to emulate because it's a ring, and some of the command will need to be applied to each ITS. So, for instance, like Raoul mentioned the sync one, if you do a sync, you need to do on the ITS. So if you have 5 ITS, you need to do on the 5 ITS in a ring and wait for them. So it's fairly messy in terms of implementation in Zen.
You mean if you emulate a single ITS?
Yes.
Yes. Just for this one.
To be honest, both of them have drawback on pros. I think we just need to pick one and see how far we can go with it.
I mean, what's the benefit of having a single ITS? I mean, is just because you have less emulated devices, or there's something else?
It's more like the way you expose to the guest. Imagine that you want to support outplug afterwards. If you want to do that with multiple ITS, then you need to expose the N ITS at the beginning. Whereas with a one-to-N ITS, then you don't have to expose multiple ITS. You just have one, and you add it on top.
That's correct. Because for a hot plug, we at least for a Linux point of view, we should need this property, MSI map property, in the device state that is needed beforehand.
I think at this stage what's more important is that all of this is hidden from the guest, so we don't start to implement the one-to-one, and then if we need to switch, we can't because the guest is relying on it. So long as it's an agreement between the two stack, and then any solution is fine.
And on the one-to-one solution, you don't seem to need to trap accesses to the MSI registers or the MSIX table or anything like that?
No.
I mean, I'm not saying... I mean, that would be quite a benefit, I think. On Zen, we have... well, on x86, we have a bit of code to deal with that, and it's not I mean, parts of it are fine, but we need to trap on mask accesses, for example, or something like that. So that makes it slightly slower. If you can avoid that, I think it would be an interesting point.
Yes, yeah,
So-
because sorry, Julian, you can go ahead. Yeah.
No, I was trying to explain a bit how the ITS works. The main thing with the ITS is the device ID is tagged by the hardware. So long you have the doorbell correct, you don't care about the event ID inside because the hardware will tag it. In theory, we shouldn't need to trap at all, except in the 1-to-N ITS. But I'm pretty convinced that some of the hardware doesn't fully respect the MSI property, or even the doorbell may not behave correctly. So we may need to trap in the future for some of the hardware.
Yeah, but I mean, that would be a workaround, not a part of the design. I mean, it would be a workaround for buggy devices. So if you have a device that's buggy, then being slow, I guess it's fine.
Yeah, but even if we need to trap it, it's not the event. We don't care about the event ID. It's just making sure that the doorbell is correct, and that can be a per PCI rather than having MSI structure within Xen.
Trap in that case, yeah, we just need to configure the real physical MSIX table to have the physical ITS address, not the virtual ITS address for 1x(n). That's why we need trap. And for 1x1, we don't need that trap because this virtual ITS virtual address will be mapped by SMMU to the physical ITS. When PCI device will write to that virtual ITS, SMMU will translate into the physical ITS and it will be written to that address.
Is it really safe to have multiple different VMs, each talking to what they think is a virtual ITS that's actually mapped to a single physical ITS?
Don't have that, please. It's a ring, so you need to make sure that the command is throttled to avoid any problems of one guest using the wall queue.
That sounds like it does need mediation.
Yes.
In which case, it's probably much easier to have one VITS per PITS in the system, because then you don't need Xen to be doing merging and duplication of ring requests.
Yeah, I think that's, well, the one-to-one stuff is that it's having one virtual ITS for physical ITS and one virtual bridge for each physical bridge.
Okay, yeah.
I suspect that is going to be an easier thing to implement.
Yeah.
So yeah, it requires lots of implementation and changes. But for this one, I already modified the code for PCI MSX that is already available for XCTS, and it is working fine as of now. This one I need to start implementing it. Okay, I think yeah. So what I will do, I will start with, I think I already implemented for 1x(n)1 and I tested to test all now as the PCI pass-through functionality as of now. And later point of time, I will implement the 1x1 when we have a 2 virtual host bridge support. I think, Alexander, that's all I have to discuss.
Yes, we can discuss that offline. It seems like we are out of time, unfortunately. PCI is such a big task. So there's not enough to talk for half an hour. Okay, thank you so much for attending the working session, for ideas and your comments. We hope that you will accept what we do on the mailing list and will understand better what we do and why. Thank you.